So now what we are going to see is oscillatory baffled reactors. Exactly as we saw in almost all previous reactors, and now we can slightly identify what exactly it is going to be. First one is oscillatory. Oscillatory means oscillation word, I think you know, like a pendulum which moves about a fixed point. Oscillation मतलब एक fixed point ना reference में आगे पाछड़ ऊपर नीचे move થાય, that is what is known as oscillation. Okay, so first word is oscillatory, second word is baffled. So I think you know what do you mean by baffled. We discussed in the previous lectures. Baffled is used basically to break the vortex. It is also used in various reactors to increase the length of the process fluid. Process fluid જે પાસ થાય છે એની length increase કરવા માટે પણ baffles can be used. Okay, so in this particular reactor, what exactly is happening? You are having very long, thin tubes. Inside that, you are having equally spaced, एकदम regular interval over, you are having these baffles. Now, these baffles are having orifice. Orifice का मतलब orifice meter is used for flow measurement, but orifice word means a hole, opening. So all these baffles, there are, suppose assume that this is your long tubular reactor. Inside this, at regular intervals, you are having baffles. These baffles are having small orifice. These baffles in the holes. Now this is the construction. Now how it actually works? When the process fluid is moving from one side to another side, along with the motion of this fluid, the reactor also moves in an oscillatory manner. It keeps on moving. Why exactly are we superimposing this particular normal movement along with this oscillatory movement? Oscillatory movement, its frequency can be 0.5 to 10 hertz સુધી frequency માં અને oscillate કરી શકો. Hertz is the unit of frequency. 1 મિનિટમાં કેટલી વાર કરો છો તમે લોકો oscillate, that is what is known as hertz. So 0.5 to 10 hertz સુધી in oscillation frequency હોઈ શકે. Now, why this is actually happening? When we are having a normal reaction, suppose the residence time is suppose 10 minutes. Okay, now for a 10-minute reaction, residence time, if you require is 10 minutes, you can, suppose if it's a large-scale industrial production, you should be using a continuous equipment, right? Because continuous equipment way. So in that case, you put the reactant from one side, the reactant should stay inside the reactor for 10 minutes and then it should be coming out. But actually, practically, this will not be very much economically feasible. Why? Because एक reactant જે છે એને 10 minutes સુધી reactor માં રાખવાનું and then it needs to come out. In that case, might be the residence time is very large for the reactor. In that case, what will happen? The length of your reactor will be very large. That will not be economically feasible. Economically, તમારા માટે possible ના થાય, because if you are talking of suppose say 10 minutes, 10 minutes સુધી તમારું જે reactor છે, this liquid, it has to be in the reactor. Just assume, suppose if it is moving at a speed of suppose say 1 meter per minute, it means 10 minutes means it will require a reactor might be 10 meter long. I just give you an example. Suppose now the speed gradually decreases more. Depending on that, the length of the reactor will increase. This will not make the continuous operation practically possible. So what happens? This is being done in batch processes. Batch process માં કરવામાં આવે. 10 minutes સુધી તમે લોકો એને batch reactor ની અંદર નાખો. After 10 minutes you take it out. Now again, batch reactor efficiency is already less. You need to add the reactants and then you need to keep it for 10 minutes. So loading unloading might take more time than actually the reaction time. Okay, suppose a batch reactor છે એને ખાલી કરો, clean કરો and prepare it for the next batch requires some cleaning, some time. So loading unloading time and the reaction time, as a result of which if you do such operations in a batch reactor, in that case also it's not so feasible. So in that case, this oscillating baffled reactor, they come to our aid. Okay, why it is so? Because here you can keep the velocity to be very less and you are having a very long tubular channel. Now again, because of the oscillatory motion, it produces something which is known as a vertical movement. This vertical word, it's very much similar to vortex. Also, it is related to vertical. Vortex plus vertical is what is known as vertical. એટલે vortex, you know, it revolves, and vertical means up and down. So because of this oscillatory motion, the vortex is created. So even combination the effect produced that, it's actually something like this. These type vortexes are created in your tube. Okay, now what happens is, because of these oscillations, suppose imagine that a vortex, this is a tube, okay, and in this you are having your baffles, our normal baffles channel. Because of this shape, a vortex is created here. Immediately the tube will go up, as a result of which this will collide here and it will break. Again, a new vortex will be created here, and then as it goes up, it will collide here and it will break. So what is the biggest advantage of this is that there will be continuous formation and breaking of vortexes. Now when vortex is formed, mixing does not take place properly. And જ્યારે vortex break થાય, very good or proper mixing takes place. So this continuous formation and destruction of vortex creates very good mixing, very much similar to a CSTR, continuous stirred tank reactor. CSTR was શું થાય? તમારા લોકોની બધી વસ્તુ components or the reactant mass is continuously mixed. Here what is happening? Some liquid is revolving, suddenly it is breaking. So when it breaks, it uniformly mixes. Again vortex is formed, again it breaks. So more is the frequency of vibration, more vortex will be formed and more it would be having proper agitation. Okay, so that is another important thing as far as this particular oscillatory baffled reactor is concerned. There is no specific internal diagram of this because the construction is simple. A long tube with baffles, and these baffles are having orifices. So our baffles ની અંદર orifices છે. So this liquid passes through these orifices and continuously vortex is produced. They are formed, they are broken, they are formed, they are broken. It leads to very good rapid agitation or mixing, and it provides very good residence time. I told you the most important thing in this is residence time. You can have this relatively very small long tube. Okay, you enter your liquid from here. At a very slow speed it will go, but because of this continuous motion, it will keep on continuously mixing. Okay, so sort of plug flow also, but the advantages of CSTR, continuous stirring, will also be there when we are talking of oscillatory baffled reactors. One question might come to your mind that in case of normal reactors, why can't we have such long reactions? Might be residence time 10 minutes more. So in that case, instead of having very long reactors, we can have very small reactors, and along with that, we can have very slow flow rate. Right? મેં તમને કીધું કે 1 મીટર જાય 1 મિનિટની અંદર, તો એના કરતાં હું સપોઝ એવી રીતના કરના હું કે સપોઝ if I increase the speed might be, or if I decrease the speed, I try to see that the reactor length is relatively reduced. But if you know, for proper mixing, unless until you are using an agitator, suppose normal BFR ની અંદર, if you want proper mixing, you need to have turbulence, and turbulence is basically determined by Reynolds number. So Reynolds number is determined by your velocity. It means you cannot keep the velocity very low. You need to keep the velocity very high. So if you keep the velocity very high, and then imagine velocity बहुत વધારે રાખો, and I need to keep that reactants for 10 minutes. So suppose if the velocity is too high, suppose say 10 meters in 1 minute. So in 10 minutes, 100 meters. So the length of the reactor will be 100 meters. So that is the reason why I told you that that is practically not possible for continuous reactors. But in this case, we can keep the velocity to be very low. Velocity સાવ ઓછી રાખો, no problem. Because here it's not the length that is important. Here the proper mixing is important, and that is not done only by the plug flow mechanism. It is done by these baffles and the vertical movement that is produced by the oscillations. એટલે આની અંદર might be even if your reactor is suppose say 1 or 2 meters long, just 2 meter લાંબુ reactor છે, but still you keep the velocity of the fluid to be very slow. Because of this oscillation and the baffles, there will be very good mixing, and the reactant will get 10 minutes time inside a very small reactor also. Clear? So that is the construction, working, basic mechanism, the comparison with normal reactors as far as oscillatory baffled reactors are concerned. Okay.